This right here is a noisy accelerometer sensor data. As we can see, it is shaky and unstable. We'll learn how to smooth out noisy sensor data in this video. Electronics such as accelerometer, photoresistor, and distance sensor can output noisy analog data that's difficult to keep steady. It is prone to shakiness. This is going to be an issue when you're performing live with an instrument that has accelerometer inside of it. Naturally, we get nervous on stage, so we don't want that hand shakiness to be audible via the synth that the sensor data is mapped to. Here's an example of what that will sound like. Good news is, there are methods to smoothing out noisy data. I'm going to demonstrate this in both Pure Data and MaxMSP. One quick and easy way is to use low-pass filter. Not only can we use it for sound design, we can actually use it to clean up noisy data. We convert sensor data into a signal that can be smoothed out with a filter, and the filter signal will be converted back into an integer or float. One thing to consider about smoothing out data is to find the right balance between smoothness and latency. As we'll see with all the methods in this video, there's a single parameter for each that will allow us to adjust the smoothness. And smoother the data becomes, more latency is added. The right balance all depends on the sensor and the context of how it's used. So there's no one single correct setting for each of these tools. Let's take a look at other methods. Another simple and straightforward approach is to use the line object. You may remember the line object when we used it for a synth envelope. This method adds small latency between data value changes, which will get rid of the unsteadiness. It's straightforward and easy to implement. So, what else is out there in the world of data smoothing? I found a helpful discussion happening in the MaxMSP forum. And Chris right here compiled all the methods that were discussed into a single max patch that we can download. So, let's check them out. These three methods do calculations with the incoming sensor data, such as taking the average or median. And all three methods filter out repetitions of a number. So slight differences between the three approaches, but they all work great. And for my Pure Data viewers, I recreated these patches just for you. And speaking of Pure Data, there's an external called mapping that we can use. It comes with objects designed to make sensor data usable in the context of instrument design, which is perfect for this channel. There are tons of objects in the folder, so we'll focus on two of them. There might be some hidden gems in there, who knows. I'm a big fan of this smooth object. By the way, it needs a Pure PD externals right here. So you might be wondering, which one of these should I use? Well, choose whichever one that quickly provides you with the right balance of latency and smoothness for your project or sensor. All of these methods work well, so try them out and go with the one that's the easiest and quickest to use. If I have to recommend which ones to use first, I would go with either Emmanuel's or Gregory's in Max. And in Pure Data, same ones that I just said, plus the smooth object. Chris's algorithm works well too, but you can use float values or large numbers for instance, as far as I know. Low pass is a bit hard to get the right parameter value with. It adds a bit too much latency. Similar situation with the line object, although I would recommend it over the low pass personally. With all that being said, I didn't spend tons of time with each, so it's definitely worth your time to go deep with them. And of course, data smoothing can happen outside of Pure Data or Max. We can build a low-pass filter on a breadboard, for example. Also, there are Arduino IDE codes that can smooth out sensor data. For example, there's an optimized code for the accelerometer that we have been using. And somebody in the Max forum mentioned that USB power can be noisy, so maybe using an external power source could be helpful too. And anyone with more experience, please do comment below about other methods that are available. Alright, that's about it. I'll see you in the next video.